class. You're welcome to another interesting segment in this very interesting series on the subject mathematics. In this segment, we'll be looking at number bases. Number bases. So first, we look at the introduction. What do we mean? Then simple arithmetic operation. We look at conversions. We take some questions, fractional conversions, decimal conversions, and so on. So let's begin. Number bases. A base just means it's just a way of counting where certain units make up a bundle. You remember your normal arithmetic, you know that counting is normally done in base 10, and in base 10, the numbers we have are 0, 1, 2, are we there?
Yes.
3, up to what? 9. By the time you get to 9, the next one you have is a bundle. What do I mean? You have 10 units, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is already a bundle, one single bundle. So we can also have base 9, base 8, base 7, depending on the base you are working. But the one that this one is decimal, or your normal base 10, you call it a decimal base. Then base 8 is what? It's called octa. Octa. In other words, you have 8 units to make a bundle. 1, 2, 3, 4, 5, 6, 7, 8. So if you look at the digits we will have in base 8, we'll start counting from our 0 again. 0, 1, 2, 3, 4, 5, 6, and what? 7. Then let's look at base 2. Base 2. This one is called what? Binary. Binary numbers. They are numbers in base 2. So as usual, you count from 0 and what? 1. Look at our definition. When you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you have a single bundle. Here, when you count up to 8 units will make a bundle. Here, just 2 will make a bundle. So we are saying we have base 2. So that means any base you have, the number of units you have is actually equal to that base. Are you getting it? So in base 2, there's something I want you to notice. In base 10, the highest digit is a what? Is a 9. One less than that, 10. In base 8, the highest digit is what? Is 7. In base 2, the highest digit is what? A 1. In other words, if you are in any base, you cannot have that digit belonging to that base. For example, base 3, you cannot have 3 as part of it. So what you have is just 0, 1, and what? 2. So let's look at simple arithmetic operations involving bases. Let's look at binary. Binary numbers. These are numbers in base 2. So let's look at simple arithmetic operations. Addition, division, whatever. So the first one we look at, the first example, as we have 101 plus 110. These numbers are in base 2. Base what? 2. This is how you put it. 2. This is also in base what? 2. You do your normal arithmetic the same way you normally do your base 10. Just the same way. There's no difference. So you have 1101 plus what? 1100. Then we had 0 plus 1 is what? 1. 0 plus 1 is what? 1. 1 plus 1 is what? 2. This is already a single bundle. So what do you have? If you get here from 0, you get to 1, you cannot have a 2. 2 is not part of the base. So instead of writing 2, what do we write? We write a 10. Is anybody lost? Thank you. 0, 1, 2. When you get to 9, you turn to 10. In base 8, when you get to 7, instead of writing 8, 8 cannot be part of it. So what do you have? You have a 10. When you get to base 2, 0, 1, the next one will be a 10. Base 3, 0, 1, 2. Instead of having a 3, you cannot have a 3, so you have a 10. In other words, 1 plus 1, instead of writing a 2, we write a what? A 10. So you are going to write 0 and carry 1. 1 plus 1 will now give you what? 2. You cannot write 2 again. Very good. You write 10 in base what? 2. These are final answers. So let's look at the subtraction aspect of it. In other words, if we want to reverse, let's pick this one again. 10011 base 2 minus 1101. Just your normal subtraction. The normal way you do your arithmetic. So we have 10011 minus 1101. Fine. All of them are in base what? 2. When you subtract 1 from 1, you have what? 0. You take away 0 from 1, you have what? 1. If you take away 1 from 0, it cannot go. So what do? You have to borrow a 1. Are we there? You borrow a 1. You cannot get a 1 from here, so you borrow the 1 from here. When it gets to here, instead of turning to a 10, in your normal decimal, the one you are used to in school, if you borrow 1 in base 2, it is actually a what? A 2. If you borrow any number in base 8, it is 8. If you borrow in base 3, it is 3. If you borrow in base 10, it is 10. You are used to 10, but we are dealing with binary number here. So if you borrow in base 2, if you borrow in 1 from here, and it gets to here, it's a what? A 2. Are we there? So from these 2, you have to borrow another 1, because this is where you want to use it. So you borrow 1. That 1 is also what? A 2. Is a 2. So when you take a 1 from 2, you have what? 1. But you already borrow 1 from here, so this one is already remaining 1. Hope you remember. Yes. We took 1 from here to here. We took 1 from here to here, so this one is remaining 1. So when you take away 1 from 1, it is 0. Is anybody lost? No. This one, since we borrow 1 from here, this one is already remaining 0. You know, we took the initial 1 from this one. So 110. So the final answer is what? 110. These 2, they mean nothing. So this is what? Base 2. If you look at it very well, it's the same one we have here. So by the time you subtract this one from the addition of the 2, we are going to have this one back. Are we there? So the third one, we are quickly going to look at multiplication. It's also possible to multiply these bases. So we have, for example, you have 101 in base 2 times what? 11 in base 2 times 11. Your normal multiplication, there's no difference. No difference. You have 101 times 1. Are we there?
Yes.
1 times 1 is what? 1. 1 times 0, 0. 1 times 1, 1. 1 times 1, 1. 1 times 0, 0. 1 times 1, 1. You roll your normal line. Then addition. If you had here, you are going to have a 1. You are going to have a 1 here. You have a 1 here. 1. So the final answer is 1 base what? 2. So next we move to conversions. So let's quickly look at how we can convert all these bases from one to another. We'll start with from base 10 to others. From base 10. Assuming we have 53 in base 10, you want to convert it to base 2. 53 in base 10, you want to change it to a number in base 2. What do? Your normal division. All these things are very easy. So you start 53, you divide 2. How many 2 can you have? You have 2 in 13, remainder 1 3. In 13 you have what? 6. Remainder 1. You use 2 again, you have what? You have 13, remainder what? 0. Hope you are there. Yes. Then you have 2 in 13, you have 6, remainder 1. You have 2, 3, remainder what? 0. You use 2 again, you have 1, remainder what? 1. You use 2 again, you now have 0, remainder 1. You bring this one, you just take it here. So if you want to get your number base 2, what do? You move this way. You now pick 1, 1. So you're going to have your answer as 1, 1, 0, 1, 0, 1, 5 in base 2. Therefore, we are saying that 53 base 10 is the same thing as 1, 1, 0, 1, 0, 1 base 2. This is how you do all the normal conversions. Let's just pick another one. 53 base 10. Assuming we are changing it to a number in base 4. Right? Okay, let's pick base 3. Base 3. The rules are the same. You just do the normal division. Since you are using base 3, use 3 to divide. If you are doing base whatever, use that number to divide. So we have 3, 53. How many 3 can we have in 5? You have 1. How many 3 can you have in 23? You have 7, remainder 2. 3 in 17. You have 15. So you have 5, remainder 2. 3 in 5, you have 1, remainder 2. 3 in 1, cannot go, write a 0, remainder, you bring the 1 down. So you move up again. Therefore, 53 base 10 is same as 1, 2, 2, 2 in base 3. If you look at it, like I said earlier when we started, all these numbers, you cannot have digit 3 in base 3. It's not possible because we are working in 3. And if you look at all this one, it's only 0 and 1 that are permitted. You cannot have what? You cannot have 2. The final conversion, before we move to how to change it back. For example, this 53 base 10, assuming you are going to base 4. You want to change it to normal base 4. In normal division. 53, 4. How many 4 can you have in 5? You have in 1. How many 4 can you have in 13? You have 3. Remainder 1. 4 in 13, you have 3. Remainder what? 1. 4 in 3, you cannot go. Write it there. Then you bring down this 3. You say remainder 3. Is anybody lost? No. So we'll go on. In other words, 53 base 10 is actually 3, you go up. 1, 1, base 4. So we'll move to how to change from other bases back to base 10. So we'll now move to converting from other bases to base what? Base 10. Let's start with base 2, our binary number. For example, you have to convert 11011. This is a number in base 2 to base what? Base 10. Very easy. This is how you do it. You write all this one outside. You have 1 times 2. You are using base 2 here. You pick this one, you just say times 2 plus, you pick this one again. Times what? 2. You pick this 0. 0 times what? 2 plus, you pick this one. 1 times 2 plus, you pick the last one. 1 times 2. This is not the end. You now begin to give them power. All the 2's, you begin to give them power. You start from the right. You start from the least one, the least significant. You give it a 0. You give this one a 1. You give this one a 2. You give this one a 3. And you give this one a 4. Are we there?
Yes.
So let's go on. This is 1 times 16. So you have 16 here. 2 raised to the power 4 is what? 16. Yes. 2 raised to the power 3 is 8. 2 raised to the power 4 is 16. Plus 1 times 8. So you have 8. This one is 8. Plus 0 times 2 is what? 0. 0 times 4. Then you have 1 times 2. 2. Plus 1 times 1. Any number raised to power 0 is what? 1. A raised to power 0 is what? 1. 10 raised to power 0 is what? 1. 100 raised to power 0 is what? 1. So you put in 1 there. So you are going to have 16 plus 8. That's 24. 24 plus 2.
26.
26. Then 26 plus 1. 27. So this is 27 is 10. That's the first answer. Assuming we are to convert this one, example 2, 1, 2, 2, 2, in base 3. You want to change it to a number base 10. To base 10. Just the normal way. You're going to have 1 times 3 plus, you pick the 2, 2 times 3 plus, you pick this other 2, 2 times 3 plus, you pick this last 2, 2 times 3. But note here, 3 is our base. So you now begin to assign power to 3. You start with 3 raised to power 0, you come to 3 raised to power 1, 3 raised to power 2, and 3 raised to power what? 3. This one is 1 times 27. It's like 1 times 27 plus 2 times 9 plus 2 times 3 plus what? 3 raised to power 0 is what? 1, fine. So plus 2 times 1. So you are going to have 27 plus 18 plus 6 plus 2 times 1 is 2. 27 plus 18, quickly, 27, 18, 5, 4. 45 plus 6, 51. 51 plus 2, 53. So you are going to have 53 this 10. But you just write 53. In other words, 1, 2, 2, 2, this 3 will give you 53 in this 10. If you can recall, this is the first example we took, or the second example we took when we are trying to change. So let's pick the last one, the final one, and we'll move on. Let me pick a number in base 8. A number in base 8. 37 base 8. You want to change it to a number in base 10. That's the normal way. The normal way. You say 3 times 8 plus 7 times 8. You assign your power to the 8. You give raised to power 0 and raised to power 1. 3 times 8 is what? 24. Plus, this one is like 7 times 1, which is 7. Is anybody else? No. By the time you have 7 to 24, you have what? 31 in base 10. You may put your 10, or you may decide not to put it. So the next one we'll move to is how to convert a base from one base, a number from one base to another number which is not base 10. That's where we'll move to next. The next one we'll be going into is how to convert from one base to another. For example, you can convert from base 2 to a number in what? Base, maybe base 4. For you to do it, you don't just go from 2 to 4. You must pass through base 10. It's very important. Example is this. If you have 1101 in base 2, and you are told to convert it to a number in base 3, for example, there are 2 steps involved. First, this is how you do it. You convert 1101 in base 2 to a number in what? Base 10. This is the first step. Next, you now change this base 10, the new number you have. In other words, the number you have in base 10, let's call the number n. The number n, you now change it to a number in base 3. This is the second step. So you go from base 2 to base 10, then from base 10 to base 3. So there's no way you can go from one base to another without passing through base 10. It's very crucial. So the example we are going to take, okay, let's pick this example we already write on the board. 11012 to base 3. So using the first step, we have 1101 in base 2. We want to change it to a number in base 10. To a number in base 10. What do we do? The number 1 times 2. Are we there? Plus 1 times 2 plus 0 times 2 plus what? 1 times 2. So you now begin to assign power to 2. 0, 1, 2, then 3. 2 raised to power 3 is what? 8. It means 2 times 2 times 2. So that's it. So you're going to have 1 times 8, 8. Plus what? 4. Fine. This one is 0 times 2. So it will turn to 0. 2 raised to power 0 is what? 1. Fine. 1 times 1 is what? 1. So 8 plus 4. 12. 12 plus 1.
13.
So this is 13 in base 10. That's the first step. So the second step, as you can see here, from base 10, you now change it to what? Base 3. So you have 13 already. So what you do is that 13 base 10, you change it to what? A number in base 3.
Yes.
So you write your 13. Have you forgotten? No. So you now begin your division. How many 3 can you have in 13? You have 4. 4. Remainder what? 1. Then use 3 again. We are using 3 because we are dealing with base 3. We want to change to base 3. Are you getting it?
Yes.
3 and 4. You have 1.
Remainder 1.
3 in 1. You cannot go.
Remainder 1.
So you are going to have 1, 1, 1, base 3. So the final answer is this. That the number you are converting from base 2, 1101, base 2 is actually 111 in what? Base 3. So this is the final answer. So I'll give you some questions to try your hands on from our question bank. Very easy questions. The first one, if 1, 1, 2, 1 base 4 equals to x is 7, find x. So look at these 3 questions. We are going to support. I want to pick just one and solve for you guys. Which one do you prefer to solve?
Question 2.
Question 2. Okay. Let me solve question 2, then you pick 1 and 3 and do on your own. Question 2. It says if 2, 4, 3, x base 5. So solution to question 2. If 2, 4, 3, x. 2, 4, 3, then x, everything is in base 5. Equals to 366. Find x. Find what? X. Hope you know 366 is in base 10.
Yes.
Fine. So the first thing we do, your normal conversion, you change it to base 10.
Yes.
Let's pick this side, the left side, and change it to base 10. So you have 2 times 5. Are we there?
Yes.
Plus 4 times 5. Plus 3 times 5 plus x times what? 5. They said is 366. So we'll now begin to give our 5. You assign powers to it. The first one you assign is 0. You assign it 1. You assign it 2. You assign it 3. This is 2 times 1, 2, 5. 5 raised to the power 3 is actually 25 times 5. Then you have, this one is 4 times 25, 4 times 25. Then this one is what? 3 times 5. Then this one is what? X. Fine. 5 raised to power 0 is what? 1. Equals to what? 366. Are we there? 2 times 125 is what? 250. Plus this one is 100. Plus 15 plus x equals 366. So let's add everything together. This one is 350. Are we there?
Yes.
350 plus 15. We have
365.
365. So we have 365 plus x equals to 366. We are looking for x, so just transfer this guy to the other side. It's going to take a negative sign. So you have 365. X is what? 1. So if x is, let's rewrite it. We know that x is 1. That means this 2, 4, 3x base 5 is actually 2, 4, 3, 1 base 5.
Yes.
So let's go. You are going to solve this question on your own. So let's go to fractional conversions. So the next one is fractional conversions. In other words, we want to change fraction to decimal. Look at it. Either from base 10 to another base, from other base back to 10, or from one base to another, but they are fractions. So the first one we'll consider is from base 10. From base 10 to others. Let's pick, maybe let's use base 2. Base 10 to binary. The first example we'll consider, I think we have 7 over 8. And this is in base 10. We are told to convert it to a number in what? Base 2. What do? You pick 7, change it to base 2. Then you pick 8, change it to a base 2. Very easy. 7 is what? When you change 7 to base 2, you have 2 in 7, you have 3 remainder 1. 2, you have 1 remainder what? 1. 2, you have 0 remainder 1. So this one is what? 1, 1, 1 base 2. So 7 is 1, 1 base 2. Then if it's 8, you are going to have 8, you have a 2, 2 remainder 0, 2. This one is 4, so you are left with 2. Remainder 0, 2 here, you have 1, remainder 0, 2, 0, remainder 1. So by the time you go, you also have 1, 0, 0, 0 in base 2. So what do you do? It's actually very easy. You just change, rather than writing 7 over, that implies that your base 7, your 7 over 8 in base 10, by the time you change it to a number in base 2, you are going to have 7, this one is for 8. So, you are going to have 1, 1, 1. Are we there?
Yes.
7 over 1, 0, 0, 0. Everything in base 2. So this is the final answer. Example 2. The second one we'll consider very quickly. Assuming you have 35. No, 35 is okay. Let's use 35. 35 over 40 in base 10. You want to change it to maybe base 8. You want to change it to an octal number. A number in base 8. So the same thing you do, 35, you quickly change it to base 8. 8 in 35, you have 4 remainder 3. You have 8, 0 remainder 4. By the time you go up, you have 43, base 8. That means 35, base 10 is actually 43, base 8. Then you come back to 40. Then the same thing, your 8 in 5 is actually 40. 8 in 40 is 5, remainder 0. 8 in 5 is 0, remainder what? 5. Hope we are not lost. Fine, that's the following. So that means 40 base 10 is actually 50 base 8. You go this way. So instead of writing 35 over 40, that means you write 43 over what? 50 in base what? 8. That means 35 over 40 base 10 is 43 over 50 base 8. So let's look at how we can go back from this other basis back to 10. How we can go back? Let's pick these two numbers again. Assuming you have, so we are going from other bases to base 10. To base 10. Let's pick this. It's very interesting. Example. You want to convert 1 over what? 8 in base 2. You want to change it to a decimal number. That's base 10. You want to change it to a decimal number. What do? You pick this 1, change it to a number in base 10. Pick 1000, change it to a number in base 10. Just the normal way. So if you have 111, you want to change it to a number in base 10, just say 1 times what? 2. Okay? Plus, you pick this other one times 2. Then you pick the last one. 1 times 2. Then this one is raised to power 0, raised to power 1,
raised to power 2.
1 times 4. 4 plus 2 plus 1 times 1. Fine. Can you see 7 already? Then we now change the second one. This one 0, 0, 0, 0. So we'll start with 1 times 2 plus 0 times 2 plus 0 times 2 plus 0 times 2. You start with raised to power 0, raised to power 1, raised to power 2, raised to power 3. This one is what? 8 plus 0 times anything is what? 0. 0 times 0. Then 0 times 0. So the answer is what? 8. Can we see that we have our number back?
Yes.
7 over 8. So that means that 111 over 1000 in base 2 is what? 7 over 8 in base what? 10. Just the way we have it here. In going this way, you can reverse back. So we're looking at decimal conversions next. As usual, we move from base 10 to others. How you can convert a decimal number in base 10 to another base? Let's use to another base. To another base. The first example we're considering is 0.625 in base 10. You want to convert it to a number x in base 2. Just watch. You do your normal multiplication. It's very simple. 0.625. You will say times 2 times 2. 2 times 5 is what? 10. 2 times 5, you have 5 here. 2 times 6 is 12. You have 1. You keep this one. Then you now remove this 2.250. You use it again, 0.250. You remove this 3 and multiply by 2 again. 2 times 0, 0. 2 times 5, 10. Carry 1. 2 times 2, 4 plus 1, 5. 2 times 0, 0. So you keep again this 0. We are keeping the 1 here. We have another 0. So you pick this 1 again. You pick 0.500 again. Times what? 2 again. 2 times 0 is what? 0. 2 times 0 is what? 0. 2 times 5 is what? 10. Then you carry a 1. But because you now have 0, 0, 0 after your decimal point, you're already through. If you have another number, maybe another digit between 1 and 9, maybe you have 5 here now, you will do the multiplication again. But now, we already have 0, 0, 0, so we already have one more number. So you pick the last one. So your answer is going to be 0. That means 0.625 in base 10 is the same thing as 0.1 0 1. Is anybody lost?
No.
No. Let me take one other example. Assuming it is 0.625 and we are trying to change it to a number in base perhaps 4. A number in base 4. What do we do? Your normal multiplication, 0.625 times what? 4. 4 times that is what? 20. 4 times 2?
8.
Plus 2?
10.
Remainder 1. 4 times 6? 24. Plus 1? 25. So, you keep these 2. You now go again, you carry this one after the decimal. You carry 0.500 times what? 4.
4.
Why are we using 4 this time? Because we are doing a base 4. Here we used 2 to multiply because we are dealing with base 2. So we have 4 times 0, you have 0. 4 times 0, you have 0. 4 times 5,
20.
5, 20.
Yes.
But here we already have 0, 0, 0. So that means we are also true.
Yes.
So you just have 2 here and 2 here. So that means that 0.625 in base 10 is the same thing as 0.2 in base 4. Very good. So let's quickly go in the reverse. Conversion from other bases. Another base. Conversion from another base to base 10. To base 10. Decimal conversion. That's what I mean. Assuming you have 101 in base 2, and you are told to change it to a number in base 10. There's one thing you need to take note. Let me show you something. These 3 digits are the one after the decimal.
Yes.
These first two, 1, they are before the decimal.
Yes.
So your normal conversion for them is supposed to be 1 times 2 plus 1 times 2. This one is what? Raised to power 0 and raised to power 1 for these two. Are we correct?
Yes.
Yes.
You will do the same thing for the others. All true. You say plus 1 times 2. But here you have raised to power 1, raised to power 0. You now have raised to power minus 1. From 1 to 0 to minus 1, minus 2, minus 3, minus 4. Just that way. So you are going to have 0 times 2 again. But this one will be raised to power minus 2 plus 1 times 2.
Minus 3.
Is anybody lost?
No.
No, fine. So, this is what we are going to have. 1 times 2 is what?
2.
You have 2. Plus. This is like 1 times 1. You have a 1. Plus. This one is like 1 over 2.
Yes.
This, if you have a raised to power minus 1, it means 1 over a. That negative means 1 over. This one is 0. 0 times 2. You have a 0. Plus 1 over 2 raised to power 3. Are we there?
Yes.
So you are going to have 3 and a half. 3 plus half. Plus what? 1
Over 2 raised to power 3.
1 over 2 raised to power 3. Fine. So that's 1 over 8. So we are going to quickly have this. 3 plus half is 3 and a half. 3 and a half plus 1 over 8. So this one is 7 over 2 plus 1 over 8. You have 8. You have 8 plus 1. So this one is like 29 over 8. So you have 3. It's remaining 5 over 8. 3 number 5 over 8 in base 10. So 5 over 8 is what? In decimal. 5 over 8 is actually, you have 5, you have 8, 0.56. Yeah, it's 0.625, so let's just use it. So we're going to have 3.625 in what? This 10. So that means 1.101 is 3.625 in this. Let me take another example to be clearer on trying to change from a decimal in another base to base 10. Very simple example. So the example we are going to take will be very clear this time. Example 2. Assuming we have 0.21, this one is in base 4, and you are trying to change it to a number in base 10. To a number in base 10. Just see the normal way that we have arrived at this. The normal way. You just have 0. No, let's start with our 2 straight. So it's going to be 2 times 4 plus 1 times what? 4. But of course, this first digit after the decimal, you use raised to power minus 1. And the next one you use raised to power minus 2. Hope you are not lost. So you are going to have 2 over 4. Just like I told you, it means 1 over 4. And a raised to power minus 1 is 1 over a. And so on. Plus 1 over 4 square. 1 over 4 square. So this one is what? 1 over 2 if you cut it. Then 1 over 16. Let's quickly do the LCM and try and solve it. You have 8 plus 1, which is what? 9 over 16. So this one is what? 9 over 16. But let's change it to a decimal. Because we are given the question in decimal. So let's return it to a decimal. It's not a fraction. So quickly, you have 9, you have 16. 16, you have 0. 16 times 5 is 80. So you can have 5. 16 times 5, you have 80. By the time you subtract it, you have 100. 16 times 6. 16 times 6 is what? 96. You have 4, put 0. 16 in, you have 3. 16 times, no, you have 2. You have 2. 16 times 2, you have 32. By the time you subtract, you have 0. You have 8. 16 and 80 is 5. 80. So this is 0.5625. The same thing as
0.5625.
That means 0.21 is 4. Is the same thing as what?
0.5625
is 10. The only one that is remaining now is how to go from a base which is not 10 to another base which is not 10. So I'll quickly give you a question. You'll be handling that on your own. It's very easy. So I'll be giving you a quick classwork. Just example. 0 point. Assuming you have 2 base 4. You want to change it to a number in base 2. I won't solve it. You are going to work on it yourself. It's very easy. The only thing you need to do, you just change 0.22 base 4. You change it to a number in base 10 first. Then from that base 10, I'm going to change it to a number in base 10. Let's call the number maybe n. Then n, which is in base 10, you now change it back to a number in base 2. We've done all that, so you can just review it. So let me give you further examples from our question banks. Further questions to work on. Further questions to work on. So I'm going to pick only, let me pick question 3. Only question 3, then you handle all the others on your own. So solution to question 3. Question 3 says, if 134 base n is what? 54 base 8. Find n. If you look at this 134, you don't even know the base. 54, we know it's base 8. So what do? You convert both the left-hand side, and the right-hand side, to what? Base 10. And now equate them. What do I mean? You see 1 times n. The base is n. Plus 3 times what? N. Plus 4
times
n. So you start with raised to power 0. Your n is now your root. N raised to power 1. Raised to power 2. Equal to 54. So you have 5 times what? The base here is what? 8. Plus 4 times what?
8.
8 raised to power 0 raised to power 1. Are we there?
Yes.
So this one is like n squared plus, this is 3n, plus 4 times 1 is what? 4. 5 times 8 is what? 40. 40 plus 4. Then 4 times 1, oh, plus 4. That's where we win. Because h raised to power 0 is actually 1. So you just say 4 times 1, then you have a 4. So this one is like n squared plus 3n plus 4 equals to 44. Let's transfer 44 to this side. So that we have n squared plus 3n plus 4 minus 44. Because it's coming from this side, the sign will change. So you're going to have n squared plus 3n minus what? 40 equals to 0. So this equation, we shall be solving. This is a quadratic equation. So we need to solve it very fast. So this one is like n, you have n squared. Which two numbers can we add? Can we multiply? We have 40, then we have. So let's pick 5 and 8. When we get to quadratic equation, you know what I'm doing here. So let's just have n plus 8, n minus 5 equals to 0. You are not lost in the segments of quadratic equation. Viewers will be dealing with it. It's very easy. We'll get to that part. So either n plus 8 is 0 or n minus 5 is what? 0. So here that means n is what? 5. And here n is what? Minus 8, because 8 will transfer to the other side. So this is what we have. N is what? 5 as our final answer. So finally, n is what? 5. That's the final answer. When we get to quadratic equation, I will show you how to simplify to have this.